Welcome to the flip side of the moon. It's no secret that it's very hot outside, and meteorologists announce new all time heat record being broken pretty much every year. Like in 2023, the all time heat record was broken. Then in 2024, that record was broken again. And it seems that 2026 may be on its way of breaking 2024's record. Astronomical events like the birth of a star from a molecular cloud takes millions of years to make what's called a protostar. In simple terms, a baby star. The death of a star is a different beast. This event happens billions of years after the birth of the protostar. Scientists estimate that the Sun, a main sequence star, will die out after 10 billion years of existence. It's currently halfway there. Those astronomical events take time to happen, and from our own little perspective here on Earth, it sounds like an unbelievable amount of time. After all, the Earth is estimated to have existed for 4.5 billion years, a literal unimaginable amount of time. Those millions and billions of years is a normal life cycle for astronomical objects in space. Literally, they're so big, right? We are a minuscule being inside of an astronomical object. So for us, a life cycle, I don't know, in average 70, 80 years. But for big planets and stars, for planets and stars, it's millions of years is their normal life cycle. But so does the eventual runaway greenhouse effect on Earth when the sun becomes 10% brighter in about a billion years or so. Earth will reach temperatures of about 47 degrees Celsius. That's 117 degrees Fahrenheit. The catch here, a change in temperature doesn't have to be astronomically high for us, living creatures, to already feel the effect. And the way we litter, it's only accelerating the process at a pace that may be astronomically insignificant. But for us, living organism, it could be a generational disaster. The hottest planets in the solar system are obviously the closest to the sun, the rocky planets, Mars, Earth, Venus, and Mercury, from furthest to nearest distance to the sun, respectively. Mercury is the closest planet to the sun, so close that some scientists believe it should be demoted to just being the actual moon of the sun. This isn't a official recommendation, more of a funny perspective of Mercury's proximity to the sun, so close that this planet can't sustain an atmosphere. Logically, a planet with such a proximity to a main sequence star should be the hottest planet in the solar system, right? But you know what I'm going with this. Mercury is not, even though it's is the closest planet to the sun. The title of the hottest planet goes to Venus, with temperatures reaching 737 Kelvin, to Mercury's cooler 440 kelvins. But how can that be possible? I hear you ask. Well, it is the very reason we are feeling the heat here on Earth. It has nothing to do with the sun. That's not completely true. The sun contributes massively, obviously, to the heat. But the other thing is the side effect of having an atmosphere. And Venus, well, Venus has a thick atmosphere. Venus is named after the ancient Roman goddess of love and beauty who was known as Aphrodite to the ancient Greeks. Ironically, when up close, the planet isn't loving or beautiful. Venus has a crushing carbon dioxide atmosphere, 90 times as thick as Earth. There is almost no water vapor. Temperatures reach 864 degrees Fahrenheit or 462 degrees Celsius at its surface. I mentioned earlier, Venus has a thick atmosphere with dense and persistent clouds. Its atmosphere traps heat in a runaway greenhouse effect, making it the hottest planet in our solar system. Well, maybe she is beautiful. A runaway greenhouse effect, keyword runaway, is where water vapor continuously traps heat until there is no more water left in the surface. In simple terms, the water runs away from the surface. On Earth and Mars, the runaway part stops because water vapor becomes saturated into ice or liquid water. More on that in a bit. Making Venus, Earth's evil twin, a hellish world. In a study published in the journal Geophysical Research Letters, of Venus's ancient climate found that it may have had a shallow liquid ocean and habitable surface temperatures for up to 2 billion years. The model used to study climate change here on Earth can be adapted for other planets, both past and present climates. However, Venus is closer to the Sun than Earth and receives far more sunlight. As a result, the planet's early ocean evaporated. Water vapor molecules were broken apart by ultraviolet radiation, and hydrogen escaped to space. With no water left on the surface, carbon dioxide built up in the atmosphere, leading to a so-called runaway greenhouse effect that created present conditions. Earth has a greenhouse effect, which is different from the runaway greenhouse effect. The sun's energy hits the Earth's surface and the planet radiates energy back into space. However, certain atmospheric gases trap some of the outgoing energy, retaining heat. The greenhouse effect is the process through which heat is trapped near Earth's surface by substances known as greenhouse gases. Imagine these gases as a cozy blanket, right? Enveloping our planet, helping to maintain a warmer temperature than it would be, than it will have otherwise. Greenhouse gases consist of carbon dioxide, methane, ozone, nitrous oxide, and chlorofluorocarbons, and water vapor. Water vapor, which reacts to temperature changes, is referred to as feedback because it amplifies the effect of forces that initially cause the warming. As I previously mentioned, greenhouse effect is dependent on the atmosphere and proximity to the sun or the amount of sunlight an object receives. In the example of Venus, which has a runaway greenhouse effect because of its thick atmosphere composed of 90% carbon dioxide due to its hydrogen that escaped to space and no water present in its surface, which makes this planet an inferno. On the other side, you have Mars. The red planet has a thin, almost non-existent atmosphere. Mars do have atmospheric carbon dioxide, but its greenhouse effect isn't sufficient to maintain heat long term. Temperatures on Mars can be as high as 70 degrees Fahrenheit or 20 degrees Celsius, or as low as minus 225 degrees Fahrenheit, that's minus 153 degrees Celsius. And because the atmosphere is so thin, heat from the sun easily escapes this planet. Finally, if we look at Titan, Saturn's largest moon, we see a moderate greenhouse effect, mostly due to the large concentrations of methane and other greenhouse gas in its atmosphere. Astronomers have compared Titan with the early Earth. It could be a suitable place for life if it were not so cold. Its surface is extremely cold, at about minus 180 degrees Celsius. Understanding which factors influence Titan's climate would be enormously helpful to us on Earth. Not to mention, Titan is 1.5 billion kilometers from the Sun, That's 9.5 astronomical units. One astronomical unit is the average distance from the Earth to the Sun, which make Titan a cold world. Earth has the ideal situation with greenhouse effect to sustain life, of course. Not only we have the right gases, we have an abundant amount of water in the surface. I often wonder why Earth isn't called planet water. From outside looking in, it looks mainly like a watery planet, but that's just me. The common misconception on Earth is that the greenhouse effect is bad. But on the contrary, the effect itself serves as our temperature regulator, helping to maintain a level of warmth to sustain life. And I'm not talking about scientists here, of course, they understand this, but I'm referring mostly to Gen Pop. But the issue that threatens life as we know it is the greenhouse gases we artificially produce. Scientists have determined that carbon dioxide plays a crucial role in maintaining the stability of Earth's atmosphere. If carbon dioxide were removed, the terrestrial greenhouse effect will collapse and Earth's surface temperatures will drop significantly by approximately 33 degrees. So it would decrease 33 degrees from the temperatures we have now. So it would get cold up in here. Well, down here. You know what I mean? Greenhouse gases are part of Earth's atmosphere. This is why Earth is often called the Goldilocks planet. Its conditions are just right, not too hot or too cold, allowing life to thrive. Part of what makes Earth so amenable is its natural greenhouse effect, which maintains an average temperature of 15 degrees Celsius. That's 59 degrees Fahrenheit. However, in the last century, human activities, primarily from burning fossil fuels, that have led to the release of carbon dioxide and other greenhouse gases into the atmosphere, have disrupted Earth's energy balance. This has led to an increase in carbon dioxide in the atmosphere and ocean. The level of carbon dioxide in Earth's atmosphere has been rising consistently for decades and traps extra heat near Earth's surface, causing temperatures to rise. Earth's greenhouse effect isn't as bad as Venus, right? But because it isn't as bad, it doesn't mean that it won't get to that point. And if we get to that point, Venus will no longer be Earth's evil twin. Venus and Earth would be the evil twin planets of the entire solar system. But I'm not going to pretend that I have a solution to this, right? I hope the big brains here on Earth think of a solution because the runaway greenhouse effect will be the legacy we will leave behind to our future generation. In the meantime, I thank you very much for watching, and I'll see you on the next one. Take care.